Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students, and subscribers for their continuous support and encouragement. Today's topic of interest is line balancing. First of all, we have to know what is meant by line balancing. It is a process of making or using our workstation effectively, and we can use n variety of products in m numbers. So that is the purpose of line balancing. For your kind information, I'm having one job. I have to do the process and make as a one finish the job. Let us say it is a gear manufacturing process. First, I have to make a machine one as a pre-machine work, pre-machining machine, say lathe. And second machine is a hobbing machine. So second machine is a hobbing machine. Third machine is a drilling and slotting machine. Drilling and slotting machine. And the fourth machine is a grinding machine. Fourth one is a grinding machine. So let us discuss about how the line balancing is performed, how the line balancing is helped. If I say for pre-machining, it takes 2 minutes to complete a job. For hobbing, we can say it takes 2 minutes to complete a job. And for the machine drilling and slotting, it takes 4 minutes to complete a job. Whereas for the grinding, it take another 4 minutes to complete a job. So what is the total time they ask? 2 plus 2 plus 4 plus 4. That is 12 minutes to complete a casted blank to the final gear piece. So for making a single piece, it takes 12 minutes. And how the line balancing gives an important picture in this way. In between 1 and 2, the lead time or machining time is same. What happen if I produce here one piece, here one gear blank, that gear blank will continue to here. So after the machine 1, it automatically takes to the machine 2, and there is no storage between 1 and 2. Okay, then what happened between 2 and 3? Between 2 and 3, we have a storage, because it is machine 2 will machine the component in 2 minutes, whereas machine 3 will machine the component in 4 minutes. Therefore, for completing one component in machine 3, the same time the machine 2 will complete two jobs. Therefore, one is came to machine shop 3, another one is stored in the bin. So here, what can we do for eliminating the storage? The main purpose is to eliminate the storage in the workshop. So what the line balancing is suggest is we have to put another machine of 3.1 of the same drilling and slotting machine, and this one component, remaining one component, is transferred to the machine 2, and we have to put in another machine 4.1. Since the 3 and 4 are having a same time, therefore the 4.1 is also needed in order to balance the line. So I hope you have clearly understood what the line balance is. Let us give you a picture. Let us give you a picture. It is a very simple example of line balancing. Let us say here the machine 1, machine 2, machine 3, machine 4, whatever may be the machines. If the operation time of the machine 1 is 5 minutes, machine 2 is 25 minutes, machine 3 is 15, machine 4 is 10 minutes. What happen if the machine 2 is machining one component means the same time machine 1 will produce a 5 component. So what happened? So 5 minus 1, therefore 4 components is stored between 1 and 2. So the machine 1 is said to be an overproduction machine, whereas machine 2 is an under constrained machine. And what happens to the machine 3 and 4? If we compare machine 2 and 3, machine 2 will produce in 25 minutes, machine 3 will produce at 15 minutes. Therefore, 10 minutes of waste time, 10 minutes of the waste time is there. So 10 minutes is a huge amount of time. When we compare it to the machine 3 and 4, we have a delay time of 5 minutes. So what the line balancing gives here, it can suggest a line, a new line, or how to eliminate the delay. These two things the line balancing will give. So I hope you have a better clarity of this picture. Let us see another one. So without line balancing, what will happen? Without line balancing, don't balance the line. So preparation department is here. Section A will have a enough component, whereas even more than enough component, whereas section B and C are still waiting. So waiting means the operator, if the operator or machine is waiting, means the indirect cost will get increased. So directly or indirectly, the line balancing helps to reduce the cost of the production. This you have to understand again. Whereas if we do the line balancing, there is no waiting time. There is no waiting time. So that is why we have to balance the line. I would like to quote an example. If you all have a chance to visit a Hyundai manufacturing company OEM at Chennai Sri Perambudur, I have visited one time. That is why I am quoting this example. I have seen that in every 72 minutes a car is being delivered, and not at all a single car. The variety of cars are being delivered. For an instant, the first car will be an I-20. I say the second car will be an I-10. The third car will be a Verna. Therefore, the different like this, I have to quote the example like this. The preparation department what will do? Say the section 1 is I-20, section 2 is I-10, the section 3 is Verna. Therefore, for an assembly purpose, the three car courses are taking the same time. Therefore, A, B, C, the three varieties will come into picture. Therefore, the three different varieties at three different uh, sections have been delivered, therefore the continuous manufacturing is happen, therefore there is no delay. In Hyundai, they are making a perfect line balancing. If you have a chance to visit, you can please visit there. So, and another an example. So if we have a mixed changeover, mixed products, the similar thing, instead of machines we have to make as an workstations. Instead of machines we put an workstation, an additional workstation, or we can remove the resources, whatever may be. The line balancing will help. So with this information I would like to go with the content which I have prepared for the line balancing. So line balancing, it is considered different workstations. Line balancing, it considers different workstation and will increase the productivity, and it decreases the ideal time. Therefore, the ideal time is reduced. Again, utilization of the resources is being increased. Therefore, the main objective of the line balancing is to increase utilization, increase productivity, and how to decrease the lead time. And the line balancing is associated with product layout. This is an important point. The line balancing is always associated with the product layout. It is not in a process layout. You have to know this better. So the product is processed, they pass through the line of workstations. As I said earlier, the gear blank have to be passed the series of the workstations like the lathe, hobbing machine, drilling and slotting, grinding, like that. The product, a single product, a gear is a product, so it have to be processed and passed through line of workstations. I said a lathe shop is an workstation, hobbing shop it is another workstation, drilling and slotting shop it is another workstation, like that. You have to, it have to cross and have to pass a line of workstations. It is shared out of sequential work activity into workstations. Sequence work activities into workstations. And sequencing, it is used for particular job. Have to know is better. Sequencing is used for a particular job, whereas line balancing is used for variety of job in workstations. We have to clearly make the difference between the sequencing as well as the line balancing. In the order we see in the textbooks, or we have a definitions, both are like to be very similar, whereas the sequencing it is used for a particular job, it is for the particular job, whereas line balancing is for the variety of jobs. So variety of jobs in the workstations can be possible in line balancing. So we have an objectives of line balancing. The objective is the various operations on different workstations in such a way that the processing time at each workstation is almost same and equal to the cycle time. So this is the main objective of the line balancing. So almost same and equal cycle time. The processing time of the workstations is almost same and equal to the cycle time. So here we have a three different workstations. So for in the first workstation we have a three jobs. So one is 542. Therefore the total cycle time is 9 and 11. Here it is 8. Here it is 4 jobs. Therefore 1, 2, 3, 6 and 11. Therefore we have a cycle time of 11 here, 8 here and 11 here. Therefore the ideal, the maximum ideal of the job is in the station 2 or workstation 2. So here we have a 3 minutes of an ideal time. So that I have clearly given in a tabular column. The total time in the workstation 1 is 11 minutes the maximum, and workstation 2 it is 8 minutes, and workstation 3 it is 11 minutes. Again the cycle time is 11, 11, 11. The cycle time is common, therefore the cycle time for the cycle time we have to take the maximum workstation process time. Here it is the both the workstations will have a 11 minutes, therefore the cycle time is 11, and in the workstation 1 it is 0 minutes idle time, whereas workstation 2 it is having 3 minutes idle time, where the workstation 3 it is having again a 0 minutes working idle time. So we have to work on station 2 in order to reduce these 3 minutes of idle time. So this is how the line balancing is being used in the shop floor. So here I would like to give an example, advantages of line balancing. The advantage it is very simple, uniform rate of production. The advantage of line balancing will produce an uniform rate of production, less work in process, effective use of facilities. Here, what is the facilities? Men, machine, men and machine, and method of production. So the effective use of the facilities and the ease of production control. Very easily you can control the productions. Okay. Next, that some of the terms used in line balancing. Terms like task time, workstation, total work content, cycle time, station time, balance delay, line efficiency, smoothness index, like that. We have a different terms which is used in line balancing. Let me see one by one. First one is the task time. Task time is a time to complete the work element. If I said earlier, in a workstation 1 we have a three jobs. The task time for an each jobs is different. So 2, 4 and 5. Yes, we know that the task time of the workstation it is 11 minutes. So this is the difference. Okay. The next one is the workstation. It is the location where the given amount of work is performed. The given amount of work is performed in a place. That place is called to be an workstation. Next is a total work content. Total work content is the summation of all tasks on the or processing time in each operation, which is called total work content. As I said earlier, so the total work content of the workstation 1 is 2 plus 4 plus 5. Therefore, 11 minutes is the total work content, where task time of completing the first job is 2 minutes, second process is 4 minutes, third process is 5 minutes. If I ask a task time in the workstation means, for completing a first process it takes 2 minutes, second process it takes 4 minutes, third process it takes 5 minutes. Like this is how we have to say the task time, where total work content we have to make the sum of all the work, all the process, all the task in the workstation, that is the total work content. Here the 11 minutes is the total work content, where 2 is the task time. I hope you have clear about these terms. The next one is the cycle time. It is the time between two successive product coming out of the production line. So the time to complete the first job and the time to complete the second job, this time difference is called as a cycle time. If I said in the workstation 1, the first process it takes 2 minutes. So the cycle time is 2. It is the time between two successive products coming out of the production line. The cycle time is greater than or equal to maximum value of workstation. Therefore, the station time, next one is the station time. It is the sum of processing time of operation on a particular workstation. So here the station time, which is equal to total work content, you have to know it better. The station time is the sum of processing time of operation on a particular workstation. So that is called station time. Next one, the balance delay is the total ideal time divided by the total cycle time. So balance delay is the ratio of the total ideal time to the total cycle time. For this, the formula is the ideal time is equal to n into cycle time, n number of jobs into cycle time minus total work content divided by n number of stations into cycle time. Here Tc is the cycle time, Twc is the total work content, and n is the number of workstations. So this formula can be narrated like this. Since there is a cancel of this, therefore 1 minus total work content divided by n number of workstations into cycle time. This is the total time. So this is the total ideal time, and this is the total cycle time. Next one is the line efficiency. Line efficiency is the ratio of total work content to the total cycle time. So total work content to the total cycle time. Therefore, the efficiency is equal to 1 minus balance delay. We can say 1 minus balance delay, or balance delay is equal to 1 minus efficiency, line efficiency. If anything between the balance delay and line efficiency is given, we can easily use this formula in order to find another one. If I know balance delay better, the efficiency is 1 minus balance delay, where if I have an efficiency, line efficiency, we want to know the balance delay, we can easily find 1 minus efficiency. So it is very simple. Next one is the smoothness index. What is the purpose of the smoothness index? Smoothness index is help to identify the distribution of load on the different workstations. So the distribution of load on the different workstation, that is called smoothness index. If the smoothness index is more, poor line balancing. If the smoothness index is less, it gives the higher line balancing. The formula for finding smoothness index is the square root of sum of the station time of the single workstation minus maximum station time to the whole square. Maximum station time minus station time the whole square and the square root. So it is inversely proportional to line balancing. The smoothness index is inversely proportional to line balancing. If we want to make higher line balancing, higher efficiency of line balancing, we have to reduce the smoothness index. So that is the thing. Next, minimum number of workstations. So minimum number of workstations, n is equal to the ratio of total work content to the cycle time or total cycle time. Therefore, the n is equal to TWC divided by TC. The actual production rate is the reciprocal of cycle time. Actual production rate is the reciprocal of cycle time. Let us give a super problem in order to find the balance delay. So we have a task like 10, 8, 6, 9 and 10. Therefore, here we know that the total number of tasks is 1, 2, 3, 4, 5. The total number of tasks is 5. The cycle time, we have to take the maximum cycle time as 10. So what is meant by line delay or balance delay? It is 1 minus total work content divided by n into Tc. The total work content is 10 plus 8 plus 6 plus 9 plus 10, and the uh, divided by n, we have a 5 stations into the maximum cycle time is 10. Therefore, if we if we if we substitute that, we came across 7 by 50, that is 14 by 100. Therefore the balance delay is 14 percentage, 14 percentage of balance delay. Here I would like to give another example. We have a three stations ABC, and we have a demand and time in a row. Therefore we have to calculate minimum number of workstations required. So for making the work time of the station 1 is 450 into 200. The work time of the station 2 is 360 into 40. For the station C is 240 into 50. Therefore, we have a work time of an individual machines is being carried on, and total work time is the sum of ABC. The sum of ABC, it is the total time. And how we get a efficient operator time is, the efficient operator time is 220 into 60. 220 into 60. Therefore it have a time we get, a number of welding lines is the total work time divided by the efficient work time we get as a 2.68 numbers. Therefore n is equal to 3 stations is required. So therefore 3 stations are required to make. Without delaying, we have to make the job very clear. So this is the agenda of line balancing. Next is the some of the process steps involved in production planning and control. In the production planning and control, the steps involved is routing, scheduling, dispatching, and follow-up. We know that what is meant by routing. It is defined as a process of deciding the path of work and sequence of operation. It is called as routing. Scheduling, which job, when to be done, how to be done, how much to be done, so that is called scheduling. And dispatching is the action or doing or implementation stage. Dispatching stage is an implementing stage. The starting of the process of production, that is called dispatching, and it provides a necessary authority to start of work. So dispatching means we have to dispatch an order to start the work. Expediting or follow up is the designed to keep tracking the work effort, work intent and planned is being implemented. We have to make a follow-up action, maintain proper record of work, delay and the bottlenecks. This is the process of expediting or follow-up. As I said earlier, scheduling, it involves the assignment of time for being and completing an operation. So with this, I have completed the line balancing. I hope whatever the content I know about the line balancing I have given. If you have any doubts, please let me know in the comment section. I will put a different video for clearing your doubt. I hope you have enjoyed the session. So thank you all. Bye bye from Santhosh. Thank you.